So today we're going to be continuing to bring up for this custom FPGA board, um, with the focus being on the QSPI flash programming today. We're going to write a simple program to blink some onboard LEDs, and we should be able to flash that. And on startup, on boot, we should be able to boot that same program afterwards. So let's just get started. So as you can see, we're back in Vivado here. As usual, we're going to be using Vivado and Vitis for this. So we've got our processing system here, just back where we left off with the DDR3 initialization. So we're just going to hop back into the processing system, go to Peripheral I/O, and we're going to select Quad SPI Flash just right here. And you can see it's MIO pins 1 to 6. And with pin 1 being a slave select, 2, 3, 4, and 5 being I/O pins. That's basically our data lines, and MIO 6 being our clock line. So these pins are also bootstrapping pins, which basically means the processing system on startup samples these pins, and depending on their state, we boot from specific devices. So in order to determine that, we will take a look at the Xilinx reference manual UG585, and we can see that based on the state of these MIO pins 5, 4, and 3, we can boot from these various devices. So on my board, similar to the RDZ7, you can boot from JTAG, Quad SPI, and SD card. So for example, if we want to boot from JTAG, we need to have all 3 of these MIO pins on startup pulled low. And for Quad SPI, you want to have this MIO pin 5 pulled high. So we can see the implementation that on the schematic here. We can see MIOs 2, 3, 4, and 5 are these data lines 1, 2, and 3. Those are basically our bootstrapping pins for this. So for JTAG, for example, we want all 3 of these to be pulled low. So we can see in this section of the schematic here, data line 1 is always going to be pulled low to ground. So in this section of this schematic here, we have this 4-pin header here with a selector switch. So if we want to boot from JTAG, we need this data line 2 and 3 to also be pulled low. So you can see by default this one's pulled low, and if we close this up, if we place our selector switch here between pins 1 and 2, this data line gets hard pulled to ground. So that would enable us to boot from JTAG. So now if we wanted to boot similarly from QSPI, we would just basically need this to be pulled, this data line 3 to be pulled high, which is MIO 5 if I'm not mistaken. That's correct, as we saw on that user guide. So this by default is pulled low. Data line 1 is also pulled low, so we just need this to be pulled high. So by default it's pulled high, and as you can see, data line 2 is going to be pulled low once we move the selector switch here. It's going to be hard pulled to ground. So in that configuration, then we would our processing system would boot from QSPI. Okay, so yeah, let's just get back into Vivado now. We've selected Quad SPI, and we want to go to clock configuration. We want to select 133 megahertz, and the reason for that is this is the part we're using by WinBond, and we can see that the clock frequency for that is 133 megahertz. So you want to just hit OK, and now we want to select the GPIO to give us access to the ports, so we can blink some of those LEDs. And for that, we're just going to open this constraint section. We're going to add a constraint master XCC file, a constraint file. So you want to hit add constraint, hit next, add files. And I've got this master XCC file that I'm going to be using. Same as the RDZ7, which is my reference manual for my custom board. So uses basically the same FPGA, so that's easy and convenient. And just add that, hit finish. Then we want to open that constraint file and uncomment the ports that we're going to be using. So I'm going to be using these 4 ports, so I've got them uncommented. You can see what package pins each port is, and you see the port name is LED. This is going to be important for our next step here. We want to go back into the diagram and add AXI GPIO, which gives us access to these ports. So run connection automation as usual, hit OK. And we're just going to regenerate that layout. So we want to go into this AXI GPIO, select all outputs since they're all going to be outputs. GPIO width 4 bits, just because we're going to be blinking 4 of those LEDs. So we'll hit OK. Now you want to hit this drop down and right click and make this GPIO port external. So you want to click on that and you want to rename it to LED, basically the same as what we had on our constraint file. So you want this external port to be named the same as what you have on your constraint file. So if we just go back here really quickly, we can see this is also named LED. So all the ports are named LED, and you see most significant bit to least significant bit. Alright, so yeah, just go back to the diagram, and that should cover the setup. So let's just validate our design now. And validation successful. So we want to run through the usual process of creating an HDR wrapper, running synthesis implementation, and generating the bit stream. And we're going to export that hardware after that. So let's just go into our design and create HDR wrapper. Okay, that's good. Now we want to generate the bit stream. Hit OK. Hit OK. And now it's going to generate that bit stream, and we're going to export the hardware to Vitis, and we'll continue from there. Also, the master XDC file for the RDZ7 you can find from this GitHub page by Digilent. So yeah, we're just gonna wait for this to complete, and we'll be back and we'll continue on Vitis. Okay, now that that's completed, just hit OK there. So all we've got to do is just export the hardware, the XSA file. We're going to use that to build our platform on Vitis. So let's just give that a second. So alright, so let's go to File, Export Hardware, hit Next, include bitstream and binary, hit Next. Yeah, we could save that there, hit Next, and finish. Okay, now what we want to do is just go to Tools, launch Vitis IDE. Okay, and we just want to do the usual. Go to File, New Component, Platform. Let's place this platform in this folder here. Hit Next, select the hardware, XSA file. There we go. Hit Next. It's going to select the operating system and processor. Alright, hit Next again and finish. And it's going to generate the platform now. Okay, now that this platform is successfully built, what we want to do is go to examples here, just get an empty application. Label this LED, and select the platform here. Hit Next again and finish. So it's going to generate that application. Application is going to go in our boot.bin file. So let's So yeah, the application is generated. We want to go into the application sources, hit new file. We want to create our C file here, main.c. So I've already got the code I'm going to be using here. I'm just going to copy and paste it. So yeah, this code basically just blinks for the LEDs on board. Pretty simple. So yeah, so that's the code. We're just gonna build the code. Yeah, it just initializes the GPIO, set the direction of output, switches on, sleeps for a bit, switches back on and sleeps. So it's just a flashing LED program here. So there we go. It's been built. So now what we want to do is, rather than running the application, or you know what, we can actually just run the application just to see that it works fine. So let's just go ahead and run it. So I'm gonna put my board here on the side now. And you see the done LED comes on. And there we go. Okay, so I'm just gonna reset that now. What we want to do next is to create the boot image. So I think in Vitis 2025, the first stage bootloader is already generated with the platform, so we don't have to do that step. So just go to create boot image here, and you see the files that you need to create your boot image. Here is the first stage bootloader, your actual your design wrapper, what we exported, that's our hardware, and the actual application here. Okay, so what we want to do is just select an output file for the boot.bin file and an output location. So we just keep it here. I'm just gonna label it boot and save. So it's gonna create that boot image based on these three files here. So the boot.bin file is what we're gonna be using. So let's create image, and it's created the boot image. And now what we want to do is we want to go to Vitis, and we want to program flash the device. Now you want to select the boot.bin file, the image file that we just generated using those three files we saw earlier. So let's go to browse, and you can see it says boot.bin file. So you want to click OK here, and yeah, then you just want to hit program after that. So let's let that run. It's gonna program flash the device now. So we have the board over here now, and you can see the selector switch is on JTAG. We move that over to QSPI, and we just hit this power and reset button, and it boots from QSPI, and we see the program we just loaded in.